A square plate of 30 mm side rests on HP such that one of its diagonal is inclined at 30 degrees to HP and 45 degrees to VP. Draw its projections. So how to start with the given problem? So here he has not mentioned whether it is resting on HP, where one of its diagonal is resting on, whether it is corner is resting on HP or the base is resting on HP. But he says that such that one of its diagonals, so he says that you have to keep the initial position of the square plate such that one of its diagonal is inclined at 30 degrees to HP and 45 degrees to VP. So that means the inclination given is at the true inclination. Suppose if I consider the base, there are two possibilities in which a square lamina can be placed. One position is it should be with respect to HP and the other one is respect to corner. So that means if I place the base, then what happens, one of the sides on HP, then what happens? The diagonals will going to become inclined to VP. So obviously you will not be able to get the true length of the diagonal in the front view when you place one of its sides on VP. One of its sides on HP. So obviously this position will going to become wrong, because if I say the diagonal AC which is inclined to EVP here, so A dash C dash will going to become apparent length. If I consider BD, so the BD is also inclined to VP, so B dash D dash will going to become apparent length, but the inclination given with respect to HP is true inclination. So if you try to rotate in the second position, you are going to get the apparent length here and the inclination given is true inclination. So I cannot rewrite this sketch in the second position front view. And obviously, so this position will going to become wrong. Suppose if you consider the corner position as we have given. So as we see, AC is the diagonal which is parallel to HP. So that is A dash C dash which is parallel to HP. So you're getting the true length in HP. So once the diagonal is placed in the corner, so AC will going to become parallel to HP. So you're getting the true length. And since the inclination given is also true inclination, in the second position when you rotate the front view, so even the diagonal will also have the true inclination or the true length. So therefore this position is right. So therefore we need to keep the diagonal as the parallel to HP. So to keep the diagonal as parallel to HP, so the initial position has to be the corner. So when you see from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and D is away from the observer, so D dash becomes invisible. And as you see from the front view, all the sides are resting on HP, so you're going to get the true shape here. So here, you can keep the square in the corner position as the surface is parallel to HP, so you're getting the true shape, and it is perpendicular to VP, so that is the reason why you are getting a line in the front view. So that line is here. So this end is also a corner and this end is also a corner. And we can see the diagonal AC, that is A dash C dash, is parallel to HP. So you're getting the true length in HP. As the diagonal AC is parallel to VP, so you're getting the true length in VP. So this is how we can place the initial position. Now he says that one of its diagonals is inclined at 30 degrees to HP. So as we see, the diagonal AC is parallel to VP, so you're getting the true length, and the inclination given is also true inclination. So you keep A dash on XY line, and when you rotate the square by an angle of 30 degree, so the diagonal is also becomes inclined, so that you will going to get the true length of the diagonal here, because AC is parallel to VP. As the AC becomes inclined to HP, so you are getting the apparent length in the HP, that is AC. In the top view, in the second position top view, that AC will going to become apparent length. But so we can see here, so this dimensions which are shown only for the reference. So in the second position, we can see the surface is inclined to HP and also perpendicular to VP. So that is the reason why you are getting a line in the front view. So we can see here the diagonal will go to become, so that we are going to see the surface will go to become a line here. So once the surface is being inclined, the diagonal AC will also become inclined. So naturally we are going to get the apparent length. So then such that one of its diagonals is inclined to VP also at 45 degrees. So the inclination given is a true inclination. So we need to find out the apparent length. Why big apparent inclination? Because in the second position top view, we can see as the diagonal is inclined to HP, so you are getting the apparent length in HP. So the inclination given is a true inclination. So on true inclination, how to get the true length? So first you consider, so we will be able to find out the beta inclination of this, and then rewrite the second position top view on that beta inclination line, and then write the front view, so that you will going to get the final sketch. So this is the projected sketch of the front view, and we can see the projected surface here, and this is the projected surface of the on the top view. So this is the beta inclination. We are going to get 54.74 here, so this is also 54.74. So on this we will be able to get the front view. So this is how you will be able to analyze the position of 3D and as well as 2D. Now we'll try to solve the problem in the. So first we're going to draw the XY line, and you mark VP and HP as shown. First we're going to consider any point, and then consider any point, and you mark this point as B, and with respect to that point, with respect to the horizontal line, you measure an angle of 45 degrees on either side, and then draw an inclined line, and by passing through the point B and also on the right side. So by using the compass with B as center, taking the radius of 30, cut an arc on this line and also on this line, you are going to get this point A and C. Through A, again you take the radius of 30, draw an arc, and from C you cut on the previously drawn arc, and you will going to get this point D. Then join A to B, B to C, C to D, and D to A with a dark line. Then draw a vertical projector from A to the XY line, draw a vertical projector from B and D to the XY line, and from C also you draw a vertical projector to the XY line. So then join B, and you mark this point as A dash, and as we see from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and D is away from the observer, so D dash becomes invisible, and join A dash to C dash with a dark line. So here this end is a corner, and this end is also a corner. As we see that one of its corners on XY line, so you consider A dash is on XY line as one of its diagonals is inclined to HP at 30 degrees. So the diagonal which is A and C, the diagonal AC is parallel to VP, so you are getting the true length in VP. So you take the true inclination with A dash as center with respect to the XY line. By using the protractor, you measure an angle of 30 and then draw an inclined line. By using the compass with A dash as center, taking the radius of A dash to C dash, with A dash as center, cut an arc on that 30 degree line, and you mark the point as C dash. Similarly, by considering the distance between A dash and B dash and transfer it from A dash on this 30 degree line, you are going to get this point as B dash and D dash, and you mark this point as A dash, B dash, C dash, and D dash in bracket. Then draw a vertical projector from A dash and draw a horizontal projector from A. Both these 2 points will going to intersect at this point A. Similarly, draw a vertical projector from B dash and D dash, and draw a horizontal projector from B and also from D. Both of these 2 points will going to intersect at this point B and also on D. Similarly, draw a horizontal projector from C and draw a vertical projector from C dash. Both these 2 points will going to intersect at this point, and you mark this point as C. And then join A to B, B to C, C to D, and D to A with a dark line. Now, as he says that one of the diagonal is inclined to VP at 45 degrees, so consider any point and then draw a horizontal line. With respect to the horizontal line, you mark this point as A. With respect to the horizontal line, with A as center, you measure an angle of 45 degrees below the horizontal line and then draw an inclined line. So the inclination given is the true inclination. So on the true inclination line, we have to get the true length. So where is the true length? The true length is in the first position top view. As we see, the diagonal A dash C dash is parallel to HP, so we are getting the true length in HP. So by using the compass, you measure the distance from A to C with A as center, cut on the 45 degree line which is drawn, and you mark this point as C1, and then through C1 you draw a horizontal line which is the locus line. Then you take the second position top view which is AC. By using the compass with A as center, taking the radius of AC with the same A as center, cut an arc on the locus line. You will going to mark this point as C, then join A to C. So this will going to be the beta inclination, and you mark that as beta. Don't use the dimension. The dimension here which is shown is only for reference. Then once you get this point, then join A to C with a thin line, and then you measure the distance from A to this point. From A you cut it on this beta inclination line, and you mark this point. Through this point you draw a perpendicular to the diagonal EC. Then you take by using the compass, you measure the distance from this point to B and also from this point to D. Both will going to have equal distances. From this point, you cut an arc on the below that line, you will going to get this point B, and from this point you take it to the top side and then cut an arc on here. You mark this point as D. Then join A to B, B to C, C to D, and D to A with a dark line. Then now we need to write the front view. Draw a horizontal projector from A dash, which is from the XY line, and draw a vertical projector from A to the XY line. So this point we are going to get it as the A dash. Similarly, you draw a horizontal projector from B dash and D dash, and draw a vertical projector from B and also from D to the front view. These 2 points will going to intersect at the respective points of B dash and D dash. Similarly, draw a horizontal projector from C dash and draw a vertical projector from C. Both these 2 points will going to intersect at this point, and you mark this point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to A dash with a dark line. This is how we will be able to solve the problem in the sketchbook and show the dimensions of 45, and instead of showing beta, instead of showing 54.74, you mark that angle as beta, and this surface is the diagonal AC is inclined at 30 degrees to HP, and then this is the square of 30 mm. Since we have considered all the parameters which is given in the problem, and hence the problem is